everyone. My name is Jonathan Alexander. I'm Vice President of Engineering at Vocalocity, located in Atlanta in the United States. And I have recently published a book called Codermetrics from O'Reilly. And today our subject is Moneyball for software teams. With that, I'll get going, and this presentation will probably run about 40 minutes, maybe 45 minutes, and if you have questions, then we will leave time at the end, and we'll do question and answer at the end of the presentation. So you may have heard about Moneyball. It is become a popular term in culture over the last decade, the last 8 or 9 years, and it is a term used generally today to refer to sports organizations that use advanced statistics to analyze players and develop strategies, and particularly the term Moneyball is most often used in conjunction with American baseball. There are many people who have been involved with the rise of this field and the term itself. There's an author named Bill James who's become very popular. He founded a kind of statistics for baseball that is referred to as sabermetrics, and he's written many books which are very popular among people who are fans of American baseball. And he has also become a full-time consultant to many leading baseball organizations such as the Boston Red Sox. The term Moneyball came into popular culture in 2003 through a book authored by Michael Lewis, who has written many other popular books, some of which have been made into movies, and which chronicled the use of advanced statistics by the Oakland Athletics baseball team, and is now made into a movie which is coming out next week, and which is kind of the reason why we're going to use this as a focus for our webcast today and our discussion today. And that movie, you may have seen, is starring Brad Pitt and a number of people and written by Aaron Sorkin. And next week, also in conjunction with the release of the movie at the Strata Summit in New York City, the O'Reilly has as one of the feature speakers Paul DePodesta, who is a vice president of baseball operations at the New York Mets, and who majored in economics at Harvard and then ended up working in baseball, and is actually one of the people who was in the book Moneyball and is featured in the movie, although I think I read in the movie that they don't use his actual name for the character. So what I want to do is I'm just going to spend a few minutes talking about the concepts of Moneyball and this use of statistics to analyze teams and strategies in general, some of the concepts that are used in Moneyball. You'll excuse me for a few minutes because we'll talk in sports parlance, and some of you may not be familiar with some of these sports, or may not enjoy some of these sports, but we'll use some general terms and concepts. And once we've gone through a little bit of introduction on Moneyball in the background, then what I want to do is spend time talking about how this can specifically apply to concepts we can use with our software teams, and talk in more detail about software engineering and kind of introduce a set of ideas that you could think about and whether they could be applied in your own software teams. So first of all, in general, this idea, as I said, of Moneyball and the use of advanced statistics has really changed professional sports, at least in the United States, over the last 10 years. And now many organizations, in fact, you could argue the vast majority of professional sports teams in North America employ people in their operations who are essentially statisticians, who come from a wide variety of backgrounds, some of which are computer science and software related, and whose job it is to analyze statistics and develop theories about how teams can better scout and draft players, how teams can analyze trades with other teams for players, how teams can develop coaching strategies and in-game strategies that will lead them to greater success. Of course, this has come into contractual negotiations for players as well, as there's much more awareness of a lot of these quote-unquote advanced statistics. There's a few key principles of Moneyball. You could kind of go on and on about some of the many principles and things that people look at with these statistics, but I'd like to highlight a few key and interesting principles, one of which is using statistics to identify undervalued assets. This was kind of the key in the book, and I think for those of us who might go see the movie, I expect it'll be highlighted there too. The term Moneyball, the reason the word money is in there is that this kind of approach to player analysis was first mostly used by teams that didn't have as much money to spend on players. And so because of their smaller budgets, they needed essentially to figure out other ways to be competitive and to win. And the key for them was to identify assets, either skills or players, that were undervalued by the teams that had more money, because those were the kinds of assets that these teams with less money could afford. So the key was to identify these undervalued assets, and they did that by analyzing skills extensively and using metrics as a way to categorize and analyze skills, and then analyze how different skills and different even strategies correlate with winning, and to therefore learn about those correlations and identify the undervalued skills or strategies that lead to winning, and then leverage that knowledge to build winning teams. And on this slide, there's a picture of a batter looking at a ball and not swinging. If you know baseball, he's taking the pitch, and this is a particular player named Kevin Youkilis, who actually is covered extensively in this book, Moneyball, when he was still a prospect. And the interesting thing is that one of the things that's discussed in the book is that the skill of being able to see a pitch and have the batter quickly deciding whether it'll be a ball or a strike, and having the ability to take pitches and to not swing at pitches that are hard to hit, turns out to be a highly useful skill in baseball that was heavily undervalued. Players that do this, usually you can find them because they walk a lot. If you know baseball, that means they go to first base without having to even swing at a pitch. And that turns out to be a very, very useful skill that was highly undervalued. Now, many of these ideas of Moneyball have become very popular, so now everybody knows about these things, and new things have to be discovered for these teams to compete. But that was one of the interesting undervalued assets discovered. Another principle of Moneyball is to use metrics to examine and challenge our assumptions about people, players, skills, or strategies. You do this by gathering statistics and looking at the situation in which you're gathering. So, for example, in baseball, looking at things that happen in different innings, in different parts of the game, early in the game, late in the game, things that happen when there are runners on different parts of the field, or in football, looking at plays that happen in different parts of the field at different times in the game, at different downs. You use this data then, again, to check your assumptions and analyze them against the facts discovered, and then adjust your strategy based on the analysis. And the pictures on this slide refer to two kind of major changes that have occurred in baseball and football over the last 10 years, mainly because of people's analysis of statistics. One is that a play that you can do in baseball, one play you can implement is called a bunt, and that's what that player on the left is doing. He's literally just going to push the ball, try to tap the ball out into the field. Mainly, you would only do this when there are runners on base and you're trying to advance those runners to the next position. That's typically when it used to be done. Many teams have analyzed now that they've come to believe that is a non-productive strategy, that it would be better for that player to just swing hard and try to hit the ball hard. And so you see much less bunting now in the major leagues. And there's other factors that come into that, but one is the situational analysis that people did. Over on the right, you see an example of a football team punting the ball. And one thing you'll notice if you watch especially professional football is that many teams punt the ball less than they used to, and they go for a first down in situations when they previously punted, usually when they're at midfield. And that, again, has come out of the situational analysis that was done over time and determined that it was a better strategy for winning to attempt to get the first down. The final principle that I want to just highlight here from Moneyball is studying and learning from outliers. Outliers are things that occur that we didn't expect. And basically, I have the definition here of anomaly and outlier, and it's really usually very hard to distinguish between the two. An anomaly is something that is inconsistent with or outside of what you expected, but basically has no explanation and really is just a random occurrence. Whereas an outlier is something that lies outside of the normal distribution or the normal sequence of events or expected events. However, the difference with an outlier is that, or at least in the way I'm going to describe it here, is that an outlier is something that is more likely to recur again, and generally, therefore, an explanation may be found as to why that outlier exists. What you see here is a picture of two baseball players on this slide, and the reason I put them here is that these are the two catchers of the 1990s. On the left is a player named Mike Piazza, and on the right is a player named Ivan Rodriguez, whose nickname is Pudge, which you see down below. And these were the two leading catchers in baseball for over a decade. And you see their statistics down below, and they both had great statistics, and they were many-time All-Stars. There's one big difference between these two players. The scouts identified when he was 16 years old that Ivan Rodriguez would be a star, and he was therefore signed very early to a lucrative contract. The scouts completely overlooked Mike Piazza, and he was therefore drafted in something like a 23rd round of a draft, basically after thousands of other or over 1,000 other players had been drafted, and yet he turned out to be one of the best players of his generation. And so the point here is that what happens in a case like this is that the analysts go back and look at, well, why did we overlook Mike Piazza, and what were the factors that would have shown that he would be a star, and what can we learn from this situation? And there's a long story there, and part of it is over time that in baseball and many sports, they have tried to move towards greater statistical analysis players because so many subjective observations often tend to be misleading. The way a person looks, their background, where they come from, all those things tended to influence people, it was found, to wrong decisions. So wrapping up on our discussion of Moneyball in sports, the basic set of techniques that are used are to gather basic performance statistics, many of which you may have heard of in baseball. They exist in other sports too, things like in baseball hits and RBI and ERA, basic statistics about how people are performing. Add other statistics that come from situational analysis or require a more careful analysis, such as errors. When a baseball player commits an error, if somebody drops the ball, it takes a subjective analysis of a person to say, was that an error or did they just, was the ball too hard to catch? Fielding and where you field on the field is now something that people keep track of. How far you ran to the ball, for example. Whether you're dealing with a pressure situation or not is now something people keep track of. Using these situational statistics and the basic statistics, advanced or combination statistics and metrics can then be formulated. Things that if you follow baseball now, there's commonly referred to statistics that no one ever talked about 10 years ago. Things like OPS, which is on base plus slugging percentage, or BABIP, which is batting average on balls in play. These are things that are now heavily discussed to categorize players into different categories, and they combine a number of other statistics. And basically then with these statistics, again, we're going to analyze, we're going to try to find the best predictors of individual and team success, and then we're going to use that to develop strategies. So now I want to shift and start talking about software teams and whether some of these ideas and how some of these ideas might apply to software teams. So first of all, this is something that I've been experimenting now within my own teams for a number of years. And what I'd like to do is talk about this and talk about some of the concepts, because I think a lot of this has to do with concepts more than real detailed particulars. And so the basic idea of how you could translate this into software teams is that you can implement new techniques to gather metrics on a wide variety of things, most of which, unless there are very few organizations that I know of that gather these types of metrics today that we'll talk about here. Some of which are there, some of which you may use already, and we'll talk about ways to get them. But first of all, we start by gathering more metrics and thinking more broadly about the things that we can measure. Second of all, we are going to figure out a way that we can measure success and failure for our teams in on projects, on the software that we produce ourselves. So we need a way to measure our successes and failures, because that becomes the key to help us analyze how our other skills, contributions, and team chemistry go into our successes and failures. And when we do that, what we're going to do is we're going to want to examine our assumptions. So we're going to want to essentially set aside a lot of our preconceived assumptions as we look at the data we begin to gather and the data on our successes and failures, and we're going to look for patterns that this information can begin to show us. And finally, then, we want to use this metrics and this information to help us focus on where we can improve, where we might want to improve, or where we might want to change or adjust some of our thinking. As an example, just to throw in a little example to start, I'd like to talk about the magic triangle, which probably many of you have heard discussed before, this concept of a magic triangle in software development, and use some general metrics taken from one software team that I was involved with in the past, and just to highlight how if we track information, then we can begin to think about our assumptions and then think about what we learn from if our assumptions are shown to be not exactly or not always the case. So the idea of the magic triangle, as you may have heard, is that there's this triangle between features, or the amount of work that we put in a software project, the amount of time that we give to the software project, and the level of quality that we'll produce in the end. And the idea is that people often say, well, you have to pick two. You can have a lot of features and fast release, but you're going to give on quality, or you can have high quality and a fixed time, but then you've got to be willing to give in on features. And in general, we all understand these concepts are true and there's a trade-off, but sometimes I think in our thinking it becomes embedded, and so we begin to think that, and what I'm posing here as a question at the top of the slide is it true that you can't add more work unless you lengthen the time or you reduce quality? And what you see is a series of releases with some information down below, and basically I've normalized this in time. Let's just, for the sake of this discussion, we'll say each one of these took an equal amount of time, or a near equal amount of time was spent on each of these releases. So the time element didn't change. And what changed, you'll see, is that the amount of work measured by the total complexity of the work items included in the release, where we rated each work item on a scale of 1 to 4 for complexity and then added all those up, that there were a couple releases, Release 4 and Release 5, that actually had a fairly high level of complexity. And yet, if you look at the numbers over on the right, actually had a higher level of quality as well. So we kept the same time, we added more features, we did not get worse quality, we actually got slightly better quality. And there is an explanation, I believe, in this particular case, and I actually think that in those particular releases, we knew how important they were, and the team was actually just more focused and therefore did a better job. And I only throw this out as an example again of using metrics and tracking to begin to look at our assumptions and then to think about the implications of that. So if what I just said is true, it isn't that then you could expect that every release we could add more work and get higher quality, and you wouldn't want to keep that as a principle, but it does make you also perhaps think about whether you could do that from time to time when you need it. So one of the things I would throw out is that when you, if you begin to think about how you can use metrics in a software team, a good place to start is to think about what questions you have and what questions you might want to answer. For example, you might want to just know how well are team members handling their core responsibilities, designing their code, coding, testing their code. And then you'd want to think about, well, what can I measure? What do I already measure, or what can I measure, and how can I measure it to know whether people are doing a good job and how well they're doing on designing, coding, and testing? You might want to know how well are team members contributing beyond those core responsibilities. Are people innovating? Are they taking initiative? How are we handling adversity? How would we measure those things, and can we measure them and figure out where are specific people good at those things and other people maybe could be developed in those areas? How well are team members helping each other? Are they assisting each other, mentoring each other, motivating? Again, these are things that you might want to ask, that you might want to answer, and therefore you could think about how to create metrics that would help you track this, discuss it, and therefore analyze it and perhaps target improvement. Is the software team succeeding or failing? Okay, this is a key one I mentioned before, and something I think in general we all can do better at is really figuring out how we measure our successes or where we could have more success. So we can look at new users or lost users. We can look at production bugs. We can look at customer support issues. We can look at the time frame to deliver certain amounts of work. All of those are things we could measure. Another big question, and putting this in line with our Moneyball and sports discussion and using some sports parlance here, another big question that I think we don't necessarily think about enough is, what are the roles on your team? How do different people play different roles, and what are these roles? And if we begin to look at different people and think about them in roles and think about our teams having roles, kind of like sports teams have roles, we can begin to think about what are the dynamics that make up more successful teams. So, for example, these are kind of, I'm using at the top here sports terms. You could come up with different terms, but you might have people on your team who are kind of your playmakers and scorers, the go-to guys who do new feature development or who handle some of the higher level, more visible tasks. You might have other people who handle fixing issues and tackling some of the harder issues to fix or deal with infrastructure issues, and you might call those people defensive stoppers. You might have people who are utility players or role players, and maybe their job is to cover just a wide range of areas, and that's what they're good at and what they're skilled at. You might have people who serve as backups, who are ready to step in when other team members are not available or aren't able to work on something. Some people might be motivators. You might have a mix of veterans and rookies and mid-level, and these are all things that I think we can begin to analyze and characterize and use metrics to get in some of the same ways that we see happening in Moneyball and in sports today. On the next couple of slides, I'd just like to show you some example metrics. I'll talk later about resources where you can go look up some of these things and find some tools to help you with this. But not to go into a lot of detail here, but the kinds of things we can measure around the skills that the developers have on a team might be things like looking at the complexity of tasks completed and the sum of complexity of tasks completed in a specific time, or looking at just the raw number of tasks completed, looking at keeping track of when people help each other and how often they help each other, keeping track of when people fix key production issues or highly severe issues, or when people take initiative and or innovate and bring new ideas to the team and help us break new ground. And also, we can look at things on the negative. We can look at when people don't complete tasks or when errors occur in areas that people work on. Then here's a set of metrics, kinds of ideas that you could look at about measuring the success of your software or a software team. We can look at new user activations. We can look at user deactivations. We can look at the rate of new activations or deactivations. You can look at trials, if you're able to gather data on trials and see how often trials convert to new users. And there'd be various ways to look at that in terms of rate, in terms of overall gain and things like that. And finally, once you have basic sets of metrics, just like we discussed people are doing in sports, you can combine metrics to build sort of meta metrics or more descriptive categorization metrics that combine those other more granular metrics together. So, for example, I have a metric here called power, which is taking essentially the complexity of the tasks worked on divided by the number of tasks to give you kind of an average complexity that somebody might of the tasks that somebody might be working on. You could begin to categorize metrics into things that help you add new features or deliver new features versus things that have to do with maintenance and support and fixing issues. So you could add different metrics together. These are like having indexes on the stock market or something like that. So these are all things, ideas of ways you could use metrics and develop metrics. And an important thing to know about this is that a lot of what I'm discussing here and a lot of the way sports teams also use metrics in Moneyball is the exact numbers in this case are not important. Meaning in sports, it isn't so important in baseball that somebody has 50 home runs versus 49 home runs. Now, it is that there's awards and things like that, and yes, there's a difference. But what they really care about in sports is that we want to know, does somebody hit a lot of home runs versus they hit a few home runs? So what we're really looking to do is to categorize. We're really looking to say, hey, people who hit more than 40 home runs, they're the home run hitters. And people who hit less than 10, they're the non-home run hitters, and then there's these other people in the middle, and there might be a few levels in the middle. The same thing applies to the kinds of things I would discuss doing in software teams. It doesn't matter if you get the data exactly right about how often somebody helps others or how many times they innovated. The thing that you're trying to do is to get general numbers so that you can categorize the different skills, strengths, and weaknesses of people on the team, to understand your roles on the team, to understand the general profile of the total team itself, so that you can begin to look at, how you might improve. So again, the important thing is you don't have to have exact numbers, and therefore you can use your existing systems. You may be able to get some of the numbers out of your project tracking or bug tracking systems. You may be able to get data, and in fact a very useful way to get a lot of data on response is just by instrumenting your software and making sure that your software reports back centrally data that would be useful to analyze how well the software is being used or how benefits are being delivered. But you can also have people self-report data, and you can have managers just spot data, or even if you're a manager and you're trying to analyze your team, you can estimate your own data based on your observations, because again, the important thing is categorization, not necessarily detailed accuracy in the regards of the kinds of metrics and uses I'm talking about. I do recommend, of course, that you're going to want to create documents or even maybe a database to store this. I think spreadsheets are great, and Google Docs is actually great as a way to store things in this regard. Once you've gathered data, now you have the ability to start to look at it, to chart it. You can use that data one value you can get out of gathering data is to increase the team awareness as to what's going on and what is each individual contributing and what things are what different strengths are individuals bringing to the team. You can get the team more focused on results. If you figure out how to gather data that points to your results and you can begin to define what results you want to achieve, then you have an ability to track it. You have ability to look at it from time to time with the team and kind of analyze how you're doing on the results that you're seeking. And you can also find creative ways, I think, to use metrics to focus in on key goals and key accomplishments. For example, I have a couple of metrics here that go to trying to measure the benefits that are delivered to existing users of a software product in each release. So trying to count up the number of benefits we deliver to the existing users, and then looking over time as to how those benefits add up versus the regressions that we have in our software releases. And that metric here is referred to as acceleration, and you could chart, this is an example of, you could have fun ways to chart acceleration that you've provided over releases and see how the team is doing. So if you want to, and if you're interested to adopt metrics and to think about how some of these Moneyball kind of techniques could apply in your software team, then I've outlined here a fairly simple and an introductory outline set of steps that you could follow to adopt metrics in your team. First of all, I think it always pays to find a sponsor. Maybe you're the sponsor, maybe you're the executive or the manager who has the authority to kind of bring this into the team. If not, I think you want to find somebody in the team who says, hey, yeah, we can at least give this a try. And really what you want to start with is that's exactly what you want to do. You just want to give it a try in a trial. And to do that, I suggest that you create a focus group, meaning a small group of people who are going to decide what the trial will be, decide what metrics you'll track in the trial, decide which team might participate in the trial, and then at the end of the trial, that focus group will kind of report out to everybody else what was found in the trial and whether or not the trial was successful. If it wasn't successful, then you're going to either restart or not go forward. But if it is successful, then you would introduce the actual ongoing use of metrics into the team or a broader set of teams. You're going to want a metric storage system, which I believe can just be spreadsheet-based, but you might want to create even a database, and it'd let you do more analysis if you did. I also recommend it's really good to establish a forum for discourse within your organization. You're going to want people to be able to give feedback. You're going to want to discuss how you're using metrics and figure out how to improve it, and that can be done in once a month lunch meetings, or it could be done in an online forum or both. And finally, if you're successful through this process, then as you've introduced a few metrics, you can begin to expand metrics used in the organization. Places and times to use metrics are in regular team meetings. I think it's very useful to bring metrics into those team meetings so that you gain awareness. That's part of the value. A large part of the value is the discussion and the observations that can come from just looking at more data about what we're doing and how we're doing it. Project postmortems are a natural. Metrics can also be very useful in mentoring and establishing goals, because if you want to improve somebody in a specific area in a specific way, it's going to be much more explainable if you can discuss the specific things that will be indicators of having improved, and then if you can look at those things together. So if you want somebody to, clearly some of the things are obvious, that if we want somebody to be more productive, well, complete more tasks, but I think that the idea here is that we might want to seek improvement in how you mentor others, or we might want to seek improvement in how much somebody innovates, or how much time they put into a certain set of tasks that they weren't otherwise doing. And again, these are things that we can measure and then point to our goals and then measure our results against goals. I don't generally, personally, like to use metrics as a basis of performance reviews, but I do like to use them, and I do suggest you can think about using them as a way to validate. Again, if you're going to give somebody a review and you're rating them in different areas, if you can't look at something you're measuring to validate why you're giving one person one rating versus another person a different rating, then I think in some sense it's becomes dangerously subjective and hard to justify. So therefore, if you can think about having metrics that you can use to help you validate performance reviews, that can be very useful and effective and make the whole process essentially more fair and more productive. And also you can use metrics as a way to track people and see when are they really kind of ready and at the level where they need to be considered for promotion. So for example, this is just kind of a made-up simple chart on the lower right, but if you had a level of performance on a certain metric or set of metrics that showed you the level that your junior coders are performing at, and you could see that the average of your senior coders or the next level up coders was at a different average level, and then you see that a specific coder has progressed from the junior level up to or at or close to the more senior level, well, that would be an indicator and a validator that they're at the time when they should be promoted. So I want to close by just talking about a couple of specific strategies that we could borrow from sports parlance and Moneyball, and this idea of bringing metrics into your team and using them, how some strategies that you might use to build better software teams or to improve our software teams. One is if you use this idea of profiling and categorizing people on your team and starting to identify the roles that people play on the software team, then as you look to add people to the team, one of the things you can do that is very popular now in sports is that you recruit for comps. And mainly comps refers to a comparable profile. So in baseball, if you're familiar with American baseball, you might be familiar with the player Derek Jeter, and of course he's an exceptional player, but somebody might say, well, I'm recruiting somebody and I'm looking for a player like Derek Jeter, or I've seen a player and he reminds me a lot of Derek Jeter. Well, that would be making a comp. So the way you can use this in your team is you would profile your team, you would identify the roles that you need to strengthen or fill. Then you would, having identified that role, you'd kind of then formulate for yourself what is the profile, therefore, of the person that you're looking for, and then you go recruit that profile. And I'm going to give you an example of this on the next slide, this particular strategy here. The other thing you can do is you can use metrics to improve your quote-unquote farm system. If you know in sports, in baseball, we have a farm system. Your farm system could be, for software engineers, could be interns. Maybe you use contractors who then become permanent employees. Maybe you simply promote from within, from one team. Maybe one team has less responsibility, and as people are good on that team, they get promoted to another team. Well, the point is that in any of these cases, again, you can use metrics. If you use metrics, then you can better analyze how the interns or the contractors or the more junior people are doing, where they have strengths, what is their profile, what kind of things are they good at, and then you can find the best placement for them or develop them, which I'll talk about in a second. Another strategy you could use is just to think about how you make trades. It's very obviously in sports, people trade players all the time. Within our own organizations, we can do that within our own software teams. We can reorganize teams internally to fill roles and better balance the skills on our teams. If you want to do that successfully or more successfully, rather than just putting people together based on our subjective gut feel, if we have more details about the real strengths and weaknesses of each team and each individual, then we can use that to better target the right fit of teams. And again, this comes back to especially helpful if we can understand what's the right mix of profiles that goes to a more successful team. And finally, we can coach the skills we need We can focus on people with specific aptitude who we want to improve to fill. Perhaps we need to fill specific roles in a team. Perhaps we need somebody who can be more of a utility player, or we need somebody who is able to be better at handling critical issues at critical times. We need to identify our candidates, and then we can use metrics to measure whether, as we're coaching, they're growing, and we can help. If we can identify clearly the areas we want to improve, and to the point that we can point out to them, how that would be measured, then we stand a better chance that they would improve in those regards. And this can go back to the junior people, our farm system as well. This is very used in sports nowadays. Is that again, I mentioned early on that in baseball, it's become apparent that players do much better if they can learn to be selective at the pitches they swing at. I'm speaking specifically about hitters, and so there's a lot of coaching that goes on now in the farm systems to try to develop that more in the players. So I mentioned recruiting for comps. I said I would just show you an example. Here's an example where if we had a team, a software team, and we wanted to find a specific kind of person, which I'm using sports parlance here, so I'm calling this person a defensive stopper. And what we say about a defensive stopper is that there's somebody who is going to be very good at fixing critical issues and handling severe production issues, and that they're going to produce a low number of errors. And that's the strength that we're looking for, and we're less concerned about their general kind of, we're not so much looking for a high level of productivity on other things, but we're looking for somebody who would be very good in those regards. Well, if we can identify that, then we can look at a set of candidates. Ideally, if they're from our farm system, then these are candidates that we could have measured and kind of found the people who seem to show a high capability in those areas. If they're people that we're interviewing, we could ask them questions about what they did before and build a mental profile of what we think their strengths are, knowing that we're looking for strengths in these particular areas. And in this example, you can see 3 candidates who we've profiled here, and candidate B is the best match because candidate B is higher in the specific regard that we're looking for, whereas candidates A and C are lower in those regards. And finally, to wrap up then, what I think, to bring it back to Moneyball, I would just say that, I think one of the things that we can all think about is what are the undervalued assets within our own organization, meaning which are the assets, which are the kinds of people or the kinds of skills that are actually really important to the success of our software teams, but which maybe we don't put enough of value on in our day-to-day project management or our recruiting, hiring, development processes. And, I think that in sports over time we've seen that people who have kind of the defensive skills, the people who do utility work, and people who are even backups, because oftentimes, you don't think about your backups, but it's pretty inevitable that backups are going to be needed. These people are often very important in sports to the success of sports teams, and they're often not, we don't pay as much attention to them as the flashy stars because it doesn't seem as important, but they're really important to the success of the team. So we can think about this in our software teams too, and again, how do we measure this and how do we categorize, and that's kind of the final thought I wanted to leave you with. So with that, I'm all done, and I'll just refer you to a couple of resources, and then maybe we can do a little question and answer. I know that took a while. We've just published a book called Codermetrics. It goes into more detail about some of the subjects that we discussed here. and you can get that from O'Reilly or Safari or in bookstores. And then what I've done is I've created a website called Codermetrics.org, and it's basically a community site, and I invite any of you to please contribute there, ideas, stories, ask questions. You can get resources there. There are spreadsheets that I've posted and that some others have posted now that you can take to use yourself. I really believe that this is an area that requires a lot more discussion and sharing among us in the industry if it's really going to develop. So I'm hopeful that we can have some activity and discussion there through that site. So with that, Yasmina, I'm all done, and I would ask if there's any questions.
Sure. We do have a couple questions that came in, and first I'd just like to let our audience know, folks, if you do have questions for Jonathan and what he's been talking to you about today, please open your group chat widget, type it in, and submit it so we can make sure you get an answer while we still have Jonathan with us. And with that, we'll start with Robert Kirkman. He asks, what are the developers' reactions to being quantified and measured? Couldn't this be divisive of the team?
I think that if you use it as, so I think that's a great question, because definitely that would be a concern. It's something I discuss in the book. I think that a key thing is not to use metrics as grades and never to introduce them as grades. And the other key thing is to have a gradual approach to introducing them, which is why I discussed kind of doing a trial and kind of gently rolling it into the process, because I do think that people, it's hard, not everybody wants to look at everything. So if you sit in your, let's say you have a biweekly sprint planning meeting or sprint review, and part of what you look at is the number of bugs assigned to each developer. Certainly there's a certain amount of discomfort in looking at everything, but if as managers, the managers and also as team members, if we all encourage each other to just look at this as we're sharing information on what's going on, and it's not a grading system, it is there to help us discuss and improve, then I think it will not be divisive, and I have not seen it be divisive. I've actually seen teams embrace it as, okay, let's talk about what's going on. And in general, I do try to focus on the positive in my own teams, meaning let's talk about how people are helping each other and how much people are helping each other. Now, if I say that, well, look, these 3 developers are really doing a great job assisting others, I haven't said that maybe these other 3 developers aren't. And what I've seen is that then people tend to take note of that, and some people then develop their own skills to follow those who are doing well in certain areas. But I certainly think it's an important thing to look out for, and and I would be very careful about how you use metrics in performance reviews and things, or it does run the danger of becoming something people resist.
Great, thank you. And we have, this came in earlier during the webcast, so I'm sure as the presentation went on, you probably did answer it, but we're just going to throw it out there anyways. Maybe the individual wants more clarification. Andy had commented, how does all this relate to development? And this was in and around the time you were talking about, the slides were saying study and learn from Outliers. Right.
So I think that, again, specifically Outliers is a good example. So hopefully we brought some of that around, and the general idea is that we can have ways to. I think what's happened in sports over the last 10 years is that essentially a bunch of people who came out of statistical analysis but who like sports are analyzing teams in new ways, and I think some of that can apply because we have teams in software too. So I think in general there's some principles that apply. Particularly Outliers, what I find interesting is that I didn't really bring this back, so it's a good point on Outliers that I think a lot of times we overlook certain types of people who turn out to be very helpful or big additions to our teams and the success of our teams. And I think those are situations that we can all examine more closely and learn from. So, if we have a profile of a particular type of person we normally recruit, we may be limiting ourselves. So we should look at the outliers and the successes that we didn't expect within our own teams when people do things that we didn't expect and see what we can learn from them and then how we can apply that going forward.
Perfect. And our final question comes from Srirang Mog, and they state and ask, Codemetrics is not only about grading people, but based on people, features, time, past user defects. Can you predict how much bake time we need so as to have a quality release?
Well, I'm not going to try to answer that last part because I think we all know that that's highly dependent and kind of the thing that the thing I'm discussing here particularly, I think that metrics and statistics, let's say, can play into many things we do in software engineering. So there's been a lot written about estimating projects and how to estimate, or there's a lot you could look at in terms of looking at rate of development bugs found and rate of work being done and rate of check-ins and therefore rate to release and timing to release. That I'm actually not talking about any of that in metrics here. I'm talking about something different, which is categorizing our teams based on a lot of what is based on observational metrics, so that we can understand the dynamics of our successful teams. We can identify undervalued skills and then give enough weight to those undervalued skills so that we keep our teams more consistent and more successful. So I'm sorry, I can't really answer that question, but I would again say that there's another way I believe we can use metrics in software, and that's kind of what we're talking about here, which is this idea of Moneyball for software teams, which is kind of a crude way to put it, but that was the topic today.
Oh, thank you so much, Jonathan, for that wonderful, informative presentation. And we thank all the attendees that joined us today. Jonathan, we had folks spanning the globe, lots of people from the UK and even Romania. And I'm sure there's more of you out there that we just don't know where you joined us from because you didn't let us know in the group chat. But we do thank you all for joining us today. And we'd like to remind you to mark your calendars. Our next webcast will be held on Wednesday, September 21st at 1 o'clock Pacific time. An artisanal approach to digital publication. And this is part of our TOC Publishing webcast series, and we hope to see you there. Again, Jonathan, thank you so much, and thank you to everybody. This will conclude the webcast. Goodbye.